Well, I've got a bunch of parts laid out here from the Airone forks, or at least one side, and they've all now been cleaned up, which took a considerable amount of effort. So we'll just go through them briefly. Main spring, fairly obvious. The topping out spring, it has a really heavy duty wire in there. The damper rod, inner damper rod tube, the fork leg. Things that start to go away from a conventional telescopic fork are the top bush, which will obviously reside on this portion of the leg. This is held into the steel tube by 2 bolts and a 3rd bolt, which is also a lubrication fitting. And at the bottom of the fork leg, instead of a conventional bush, we have this arrangement consisting of, I guess you'd describe it as a shoe and a roller. So if I slot that on, you can see that the shoe is a nice fit. A little bit hard to keep all this aligned. And then there is a roller, and the shaft on which the roller runs, if I can get it in the right position, is eccentric, so that the clearance to the tube can be set, and the roller hopefully will roll. I believe one of the issues with these forks is that the roller isn't always rolling freely, and you end up with a flat spot, and then you're doomed because it's unlikely to start rolling again. The roller and the shoe on this appear to have been replaced sometime in the not too distant past, and hopefully will work okay. The pin and the eccentric pivot are okay. I think they're usable. At least the first instance, I want to get the bike on the road and see whether it's something I enjoy riding and want to keep. And then I'll think about buying or making replacements for these. But anyway, that's the arrangement here. You can see on this side, this still needs cleaning up to some extent. You have a plate that goes on the eccentric and allows it to be rotated, and then the cover plate for this piece has an attending slot, an outer plate, and then a bolt goes through and locks it to this outer plate to prevent rotation. So it's quite an unusual design, but quite clever in its way. And getting it back together is going to be mostly straightforward, but there is a little issue on the damper rod. Now this is the damper rod from the other side, and obviously the bottom seal's off. Now I got a set of seals from Italy. This is an Ariete set. You have a seal for the bottom of the damper rod. These seals that replace what would originally have been felt seals that go in the bottom of the steel tube assembly and keep the lubricant inside the leg and keep dirt out. And then you've got the seals that go at the top of the damper rod. Now, according to some sources, what you're meant to do is to simply pull the seal out and put a new seal in. And I've started doing that here, and the washer on top of the recess, getting the seal out, you know, I've only done a partial removal here. If I carry on pulling it out, and that's a really hard seal, but trying to get the new seal through that hole, and this hole's rather beaten up. Now, when I did that on the other side, the washer popped out, and looking at the parts list, the washer is listed as a separate part, and trying to get the seal back through a hole in a washer, and these are just off the shelf washers, but the hole's pretty much the same size. Trying to get that seal through that washer, even if folded up, doesn't seem a very sensible thing to do in terms of not wrecking the seal. And you know, that washer is a loose fit in there, but it's not the same size as the originals quite. I think these washers were probably pressed in, and the idea was just to pull them out and replace the seal and press them back in again. Now, this has got a lot of evidence of having been bashed about, possibly in an attempt to retain a washer, because you know, no automotive machinery, you know, or certainly not ordinary motorcycles and cars, are built for multi-decade lifespans. The manufacturer's thought is that they're going to be replaced, and so something like replacement of the seals may not be done very many times in the vehicle's life. So if they could be replaced, you know, twice, maybe, you'd probably be doing a lot of miles. You can see on this side, this one's much less beaten up, but there is evidence of screwdriver marks. You know, I wouldn't want to be, I'd have difficulty certainly on the underside where it's also scarred. So certainly my approach is going to be to put the seal in and then press in, and if necessary peen in place a new washer. So what I think I'm going to have to do is to build this up with weld, machine it back, then put in the new seal and the washer, and then peen it, or think about coming up with some other kind of arrangement. Okay, you can see the less than spectacular TIG welding, but we've got material built up where we need it, and I can put this in the lathe and machine it back. I'm going to start off by facing this back to clean metal. I'll give it a quick measurement, and then I'll decide what length of material I want to leave extra compared to how it was originally. Okay, I want a height of 3.3 millimeters. At the moment I have got 3.94, So put that in the DRO. And take that down to required length. It's a pretty good finish on there. So with 2 lengths, now I need to clean the bore up. So I've got a solid carbide boring bar here with a CCMT style tip. So I'm just going to first of all just clean up so I can get a measurable diameter. Now I'm going to have to go a fair bit further for me to be able to measure that, but it gives me an idea that there's plenty of material in there. Okay, that's at least something that I can measure. I'm not going for precision at the moment, I just want to have an idea of where I am. It's still a way off. I bought that to 14.5. The small bore that we need in there is 16. I'm going to go straight up to 15. Just want to pull some of the swarf out of there so I can see what I'm doing a little easier. Still a ways off having plumbed in air in here, so toothbrush comes in handy every now and then. So I'm going to take that out to 15.5 and then break out some more precise measuring instruments. Should just have enough thickness to go in there with the snap gauge. We're a little bigger than I originally measured with just the calipers, but plenty of material there to be safe. Let's recalibrate the DRO. And I'm going to go out to 16.9, remeasure, and then take the final. But first of all, I'm going to touch off at the bottom of the hole and set a Z data. What I want to do now is get the tool positioned so I'm not hitting the bottom of the hole, and set up a hard stop. This is our going to be our 15.9mm cut with then a final to depth of this is going to be our 15.9mm cut, leaving us 0.1mm as a finish pass. And I now know where the bottom of the hole is, so I can watch that on the DRO as well. Critical dimension, it's just for the OB of the seal, and there is a little bit of leeway there. It's a rubber seal. go, and we're not quite touching all the way around. This is a pretty good 3-jaw, but there's been a little bit of run out, but I'm happy with that as the seal bore. I'm going to back the tool off into the centre of the bore, well out the way, and move the carriage to about 3.2 millimeters, and then I'm going to bring up the bed stop and lock it in. And with the feed wheel pushing the carriage up against the stop, I'm going to adjust the stop until the DRO reads 3.1 millimeters, just there. Lock the stop. So I can take a 0.5 millimeter pass, no problem at all. So we're out to 16.5 and into the stop. We just caught a chip there. Don't see any problems with the finish of the bore. It's just a oil mark. Yeah, and we're agreeing with the DRO still, so I'm going to take that final pass to 17 millimeter finish size. So that obviously needs to be chamfered now and given a decent clean up. So I've got the bed stop in the way. And I'm going to do some clean up on the OD, and then we'll be ready to fit the seal, press the washer in and stake it in place.